All right. So, how's it going?
Yep.
It's going.
Yes?
Honestly, I have better.
Are we gonna have
I have so much stuff to do today.
What did you say? Sorry?
We're gonna have IXL.
No.
I saw
There's
him
just
again.
one assignment for the week. And there it is.
Or yesterday, actually.
Okay. Any questions on that stuff, by the way? Finding limits involving trig functions. Remember, there's the 4 special limits.
We only have to go for 90. Yes.
Yeah, a 90 is 100. But an 89 is an 89. So it doesn't scale from there like that. Okay. So there's a test tomorrow. Talk about what's on the test. So it's about finding limits analytically. That just means without the benefit of knowing what the graph looks like. So remember, there's like a flow chart of steps that you would try. Okay, so for some of them, you just plug it in. Plug in the X value. If that works, then you're done. Right? The next thing you should try and do is to cancel common factors. If you can do that and then plug in the X value and you get an answer, then you're done. The next thing you would try and do is other algebra. Which may or may not include rationalizing or getting rid of complex fractions, etc. So rationalizing. Complex fractions. Etc. So this etc. might include, like, there might be parentheses and stuff like that you can, or like a binomial that's cubed or something that you can FOIL it out and then stuff would cancel. Okay? So if you try all of these things and you still get a 0 in the denominator, then there's a situation where you have a vertical asymptote. Okay? So you can actually tell if there's vertical asymptotes right away by substituting the number, and if you get a 0 denominator but not a 0 numerator, then that means that there's a vertical asymptote. Then you're going to get an infinite limit at that point. Okay? Then we talked about limits to infinity. And remember, the bottom line here is if the bottom grows faster than the top, a faster rate, then the limit's 0. If the top and bottom are growing at the same rate, then the limit is like the fraction of leading coefficients, kind of, most of the time. And if the top is growing faster than the bottom, then the limit is infinity, or negative. Okay? So you need to be able to look at limits to infinity and determine when a function has horizontal asymptotes. Horizontal asymptotes are going to occur if the bottom's growing faster, because then it's 0, or if the top and bottom are growing at about the same rate, because then it's an actual number. If the top's growing faster, there's no horizontal asymptote because it just goes to infinity. Okay? And then we also talked a little bit about piecewise functions, how to determine when piecewise functions, or limits of piecewise functions, at the point where they change, where the functions change. So remember, the whole idea there is, if it's 2 pieces, and say that the pieces change at x equals 2. to find the limit as x goes to 2, you would just substitute 2 into the first function and 2 into the second function. If you get the same answer, that means that the functions are headed towards the same spot. If you get a different answer, then the limit doesn't exist because they're headed towards different spots. Does that make sense? Logically? Okay, and then the last thing about this chapter was just determining, or talking about the definition of continuity. What it means for a function to be continuous. There's 3 things that have to be true. The function has to be defined at that point, the limit has to exist at that point, and those 2 things have to be equal. Like f of a has to equal the limit as x goes to a. Those are the 3 things that have to be true. So that assignment in Delta Math was just walking you through that definition. Okay? We know, like you can tell by looking at the graph where it's not continuous, but is that because there's a hole, in which case the function's not defined, or is that because there's a jump, in which case the limit doesn't exist, or some other reason? Okay? Does everybody understand what I mean by that? All right, so that's what the test is on tomorrow. Any questions? Anybody want me to do any of these for practice? And remember, you can always look back at Delta Math, old assignments, even if the due date is passed, and you could do a problem or 2 in a section for your own, like, you know, comfort level or whatever. Okay? But you can't do it once the test starts. Delta Math won't let you. Okay? Any questions then? All right, I just want to talk about one more topic today that has to do with finding limits analytically. And it's something called the squeeze theorem. Squeeze theorem. And sometimes this is actually called the sandwich theorem. It depends on the textbook. Sometimes it's called the squeeze theorem. Sometimes it's called the sandwich theorem. And here's what it states. Okay, when I write these words and these symbols, it's going to be a little bit confusing, but when I draw the picture, it's way less confusing. So here's the words and symbols. Okay, if f of x is less than or equal to g of x, which is less than or equal to h of x. So you have these 3 functions. One of them is always on the bottom, one of them is always on the top, and the third one is always in the middle. That's what this is saying, right? If this is true, then for any x value, x equals a, where the limits exist, the limit as x goes to a of f of x less than or equal to the limit as x goes to a g of x, which is less than or equal to the limit as x goes to a of h of x. Now that might seem kind of obvious, but it's used in a really important way. Sometimes you'll have the function that's always on top and the function that's always on the bottom. They might actually meet at a certain point. Well, if that's the case, then g of x actually goes to that same point. Does that make sense? If you have one that's always on top, one that's always on the bottom, and one that's always in the middle, and the top and the bottom one touch each other at a certain point, then the one that's in the middle has to touch those other two at that same spot. Has to be true, just logically, right? So what I'm saying is, the picture would be like this. I have F, which is always on the bottom. Maybe it goes like this or something. This is like F of X. I have H, which is always on the top. So maybe it goes like this, but they touch at a certain point. So say this is like H of X. So what this is saying, the same theorem is saying, is if you have a function that's always somewhere in the middle, then it has to go through that same point, E of X. You have to meet at that same point. So how is that useful? It's useful if you have this function g where you can't figure out what the limit is at x equals a, but you can figure out two functions, one of which is always above it and one of which is always below it, and those two limits end up being the same value at a. Everyone understand what I'm saying? Like if you know that the limit as x goes to a of f of x equals the limit as x goes to a of h of x, well then the limit as x goes to a of g of x has to be that same thing as well. Does that seem logical from my picture?
Yeah.
So let me just show you how this would be used. Suppose I have something like this. What if I wanted to take the limit as x goes to 0 of x squared times the sine of 1 over x. I don't really have an easy way to evaluate this limit. If I just plug the number in, I get 0 here, which leads me to believe that maybe the answer is 0, but I get does not exist here because the sine of 1 over 0, that's going to be like as x goes to infinity, and the sine value just bops back and forth and back and forth. As x goes to 0, 1 over x gets bigger and bigger, right? So that means the sine value just keeps going back and forth. It doesn't settle on a particular value. So even though it might seem like the answer is 0 here, I'm not sure because this part of it does not exist. And 0 times non-existent isn't necessarily 0. Maybe it's non-existent. You know what I mean? It's not really clear. Like the rules of math aren't really clear as it relates to that situation. 0 times does not exist. Maybe it doesn't exist. Maybe it's 0. Okay? But we can actually find this limit by using the squeeze theorem, sandwich theorem. Here's the way it would work. I would say, first of all, I know that sine 1 over x is always between -1 and 1. That's always true, right? The sine of something is always between -1 and 1. Never beyond that. That's its range. Everybody comfortable with that?
Mm-hmm.
So then I could just multiply this by x squared, multiply this by x squared, and multiply this by x squared. That's perfectly legal algebraically because x squared is positive. I can multiply all three terms of this dual inequality by a positive number and nothing changes, right? In that case, I get -x squared is less than or equal to x squared sine 1 over x, which is less than or equal to x squared. Well, this is the precise situation that I was describing when I was talking about the sandwich theorem. We have x squared, which looks like this. We have -x squared, which looks like this. And we know that x squared sine 1 over x is always in the middle between them, right? So maybe it looks like this. I mean, I don't really know what it looks like, but maybe it kind of goes like that, right? But the bottom line is, if I know that the limit as x goes to 0 of -x squared is 0, which it is, right? I can just see that from the graph. And I know that the limit as x goes to 0 of +x squared is 0, then doesn't it have to be true that this limit is actually 0? Definitely true, right? So that's the justification for how we know that's true. We can't say 0 times non-existent is 0, because that's not true always in math. Sometimes that's not true. Sometimes it doesn't exist. Okay? But in this case, it's 0. Okay? Everyone kind of understand that? Let's just do one more example of this squeeze theorem. Suppose we have something like the limit as x goes to infinity of cosine x over x. I know, like, we have a rule that looks kind of like this, but not really, that deals with sine, right? And that rule says if you take the limit as x goes to 0 of sine x over x, you get 1, right? That's the rule. But this isn't exactly that, right? So those special trig limits that we talked about aren't helpful here for 2 reasons. First of all, it's a sine, it's a cosine and not a sine. And secondly, it's going to infinity and not to 0. So it's not really helpful, okay? But we can use the squeeze theorem. Here's the way it would work. I mean, it's kind of a similar process that I just did in the previous problem. I'm going to say cosine x is less than or equal, or greater than or equal to -1, less than or equal to 1. And then I'm just going to divide everything by x. Now, normally, you're not allowed to divide or multiply by something that's negative without changing signs, like switching directions of inequalities. Why can I do it here? Like, why can I divide by x, divide by x, and divide by x? Yeah, because x is going to infinity, so all the numbers I'm concerned with are positive, right? I'm going to positive infinity, so that's why that's allowed here. In the previous problem, it was allowed because I was multiplying by x squared, which is always positive. And here, I'm dividing by x, which is positive in the neighborhood I'm concerned with. So I have the same scenario here. I have 1 over x, which, remember, that's like the inverse variation hyperbola. It kind of goes like this in the first quadrant, and then it's like down here as well, which I'm not really going to draw. I'm just going to do that. And then I have negative 1 over x, which is just the reflection over the x-axis. It goes like that. And I have this third function, cosine 1 over x, which is somewhere in the middle. Maybe it looks like this. But the point is, and the way that the squeeze theorem works here is, if I know that the limit as x goes to infinity of 1 over x is 0, which it is, look at the graph, and I know that the limit as x goes to infinity of negative 1 over x is also 0, which it is, look at the graph, then the third function that's always in the middle has to go to 0 as well. So this answer would be 0. Now, it might seem like squeeze theorem problems, the answer is always 0. But that's not quite true. It's very common because it's a little complicated to come up with examples. It's hard. I was trying to think of examples, and I actually couldn't really come up with any. So I Googled it, like examples of the squeeze theorem where the answer is not 0, and they were like super like crazy problems. And so, you know, oftentimes they're 0, and oftentimes they involve trigonometry. I just wanted to give you like 2 scenarios where this theorem would work. And basically, I just want you to remember that this is the thing. Like, it makes sense logically if you just think about it. If the functions like come together like that, then any function that's in between them would have to like come together at the same spot. That's kind of the point. And that's it. Any questions about that? It's not going to be on the test or anything.
Can you fill out the line?
Yeah, sure.
Just to the top of the, yeah. Okay, that's all.
Okay. Yep. So the stuff we talked about this week isn't going to be on the test. There's a special trig limit problems, not on the test. And squeeze theorem problem, not on the test. Okay? The test just includes what we did like before break. All right.
Sarah, what did you think of Emma's?
Yeah.
Huh?
Nice food.
Kind of spook?
It was good. I didn't like love the ending.
I didn't either.
I think that it was really spooky and the ending made it less.
Yeah.
I mean, like it was satisfying because like obviously you want the murderers to get into jail, but it makes it less effective.
Right, and his like complete smugness is also. I don't feel like he was characterized enough. You know what I mean? For that to really feel from
I
him.
really do a lot of like.
We're doing like,
have more about the
Oh, you're doing too? All right, so we're doing.
Yeah, it really doesn't
Then in
let
the
you
middle
connect
of
with the
it,
women and
I
like
want people to
sympathize
come
with them.
back to the track.
Yeah, and obviously like when you're writing from the murderer's perspective, there's only so much you can do, right? But that there's
That's
different
what
things
we're
like
done.
affecting its
That's what we're
mother.
But
Really
maybe
sold
we'll
it.
still be there.
Yeah.
Yeah.
Yeah, I agree.
Thanks.
Oh, obviously I agree. I'm the one who said it.
I agree with you. I agree.
It's like, wow, really?
I read a book, and the person who wrote it quoted themselves in it, and I think that's the funny thing. Like, I hope to be that iconic one day, that I can write a book and quote myself.
That'd be so great. That'd be so boss. That's never gonna, I feel like that is the ultimate form of narcissism.
Isn't that weird though? Like, you can like plagiarize yourself.
Which is great.
Wait, you can?
You can't.
Wait, how? What?
If you
There was a
like,
person
use
who-
content from another two publications and you don't edit it properly,
No, I
you
was
plagiarize yourself.
and like.
I use stuff from my old essays like literally
I'm like,
constantly.
in
Five ideas that I started like.
like in music too, there was somebody who got sued for plagiarizing himself because he didn't own the rights to the music that he wrote before.
That's so funny.
There was somebody, it like, I think it was Clearwater Revival, who wrote all the songs and then went to the solo artist and wrote more songs, but then it was exactly the same. Because it's the same
Whatever.
person, but he didn't own the rights to the other songs, so he got sued.
So funny.
Have you ever got the same style of yourself?
Music plagiarism, like,
It's weird.
like, litigation is
Very strange.
very interesting. There was a mathematician who wrote an algorithm that determined like the extent of plagiarism between songs. And it's like, it's pretty,
That's so, how do you even,
right?
I've seen that actually.
that's so interesting.
I mean, it's kind of hard because like there's certain sounds that are killing, right? And there's only so many sequences that we can come up with. Yeah.
I don't know if I just like analyze the like sonic waveform of the songs to like determine.
It's basically impossible for that case to say original forever.
One finds how similar music is.
You have to break more like musical boundaries, I think. Think about that.
It's one of the issues that people in Western civilization are stuck in the Western box of current music.
And also, Western box of everything you need.
I mean, yeah, but, okay, yes. Yeah. Yeah, so it's limiting, because people come
But Western classical music is better because science. Science.
what? I had that conversation with someone, I was like, no, but, like, no, and I'm like, yeah, science says it.
Elaborate.
Oh, I've been recording the whole time. I just stopped recording.
That's okay.
Sorry.
I know how Western civilization works.
Yeah.